Welcome to the DIY Honda Garage channel. This presentation covers the DTC P16BB, which stands for Alternator B-Terminal Circuit Low Voltage, specifically for the Honda Civic models from 2016 to 2021. DTC codes, or Diagnostic Trouble Codes, help identify issues within vehicle systems, and P16BB indicates a voltage problem in the alternator circuit. The alternator plays a crucial role in charging the battery and powering the vehicle's electrical systems. If this circuit is experiencing low voltage, it can lead to various electrical issues, including battery drainage and malfunctioning components. We will explore the causes, symptoms, and troubleshooting steps associated with this DTC, providing a roadmap for effective diagnostics and repairs. The DTC P16BB specifically relates to low voltage detected in the B-terminal circuit of the alternator. The alternator is responsible for generating electrical power while the engine is running. It charges the battery and supplies energy to the vehicle's electrical systems, including lights, radio, and air conditioning. The B-terminal is a vital connection point that facilitates the power transfer from the alternator to the vehicle's electrical network through the underhood fuse relay box. When this circuit faces low voltage, it can cause several electrical components to malfunction or fail to operate efficiently. This issue usually necessitates troubleshooting to identify any broken or poorly connected wires, ensuring that the alternator can effectively output sufficient voltage for the vehicle's operational needs. Several factors can contribute to the triggering of DTC P16BB. One typical cause is poor connections at the alternator itself. If these connections are not secure, the voltage may be inadequately transmitted to the underhood fuse relay box. Additionally, loose terminals at the fuse relay box can prevent the electrical flow necessary for proper vehicle operation. Another possible cause is an open wire between the alternator and the underhood fuse relay box, often due to wear or damage in the wiring harness. Each of these conditions must be carefully inspected to determine the root cause of the DTC and ensure proper voltage levels are being maintained. When DTC P16BB is triggered, various symptoms may manifest in the vehicle's operation. A key indicator is the illuminated battery warning light on the dashboard, signaling the driver that there is an issue with the charging system. Additionally, electrical systems may begin to malfunction. For example, power windows or radio could exhibit erratic behavior. Drivers may also notice dimming headlights, especially when additional electrical components like dashboard lights or air conditioning are activated. These symptoms suggest insufficient voltage is being supplied to the electrical systems, reinforcing the need for thorough diagnostics to rectify the issue at hand. The first troubleshooting step involves verifying the problem by turning the vehicle to the on mode and utilizing the Honda Diagnostics System, HDS, to clear the existing DTC. Once the DTC has been cleared, the next step is to start the engine. Following that, specific testing conditions must be implemented. It is essential to activate various components, such as the AC on maximum cool, the blower fan at the highest speed, and the headlights on high beam. Additionally, the rear window defogger should also be engaged. The goal is to hold the engine speed at 2,000 RPM without any load for 1 minute to clearly assess the alternator's performance under specified testing conditions. Finally, recheck for any pending or confirmed DTCs using the HDS. In the second step of troubleshooting, the focus shifts to inspecting the connections and terminals, specifically at the alternator and the underhood fuse relay box. The +B line, which is crucial for voltage supply, must be checked for any signs of wear or disconnection. If the connections are found to be loose or inadequate, repairs need to be made to secure them and ensure proper electrical flow. A thorough examination must determine if the connections are satisfactory or if they have been compromised due to corrosion or mechanical failure. If satisfactory connections are confirmed, the technician can proceed to the next step to check the wiring integrity. The third step involves checking the wiring for any potential opens, particularly in the wire between the alternator and the underhood fuse relay box via the engine harness. This step requires careful examination of the wiring for signs of damage, fraying, or disconnection that may inhibit proper electrical signaling. If the wiring appears intact and the harness connection is confirmed to be okay, the next action would be to replace the alternator, since it may be malfunctioning due to internal faults. Conversely, if an open in the wiring is detected, it necessitates repairs to restore continuity in the +B wire, ultimately ensuring that the alternator can provide adequate voltage to the vehicle's electrical systems. Following the troubleshooting steps and any necessary repairs, it's vital to verify that the alternator is functioning properly. This verification process includes checking the alternator's output to ensure that it effectively supplies the necessary voltage to the vehicle's electrical systems. Additionally, using the HDS, the technician should confirm that the DTC P16BB does not reappear, indicating that the previous problems have been adequately rectified. Finally, it's important to test the vehicle under normal driving conditions to ensure that all electrical systems operate as expected without any anomalies. This thorough check confirms that the repairs have resolved the issue and guarantees the vehicle returns to optimal operating conditions. Preventive maintenance is crucial in maintaining the functionality of the vehicle's electrical systems and avoiding future occurrences of DTC P16BB. Regular inspections of electrical connections, particularly at the alternator and fuse relay box, can help detect potential issues before they escalate into major problems. Routine checks of the alternator's performance will ensure it remains efficient and can supply adequate voltage. In addition, the health of the battery should also be assessed periodically, as a poorly performing battery can lead to voltage discrepancies. Implementing these proactive measures contributes to the longevity and reliability of the vehicle's electrical systems. In conclusion, understanding DTC P16BB, which corresponds to alternator B terminal circuit low voltage, is essential for maintaining the integrity of Honda Civic models from 2016 to 2021. Identifying the symptoms and causes of this issue is the first step towards effective diagnosis and repair. By meticulously following the outlined troubleshooting steps, technicians can accurately pinpoint the source of the problem, be it poor connections, open wiring, or an alternator malfunction. Furthermore, implementing preventive maintenance ensures that potential future issues can be addressed early, safeguarding the vehicle's performance. Overall, being proactive and informed is key in dealing with electrical system issues, ensuring a smoother driving experience. Please like and subscribe to the channel. See you next time.